All right, welcome back. We are doing more of finding roots. And this one, we're going to be finding roots of quadratic functions. So I'll tell you a couple different ways to find the roots, and then I'll tell you my preference for each one of these, because I think I'm going to be solving each one of these differently. So we're in 3.7. This is number 22, 24, and 25. So 22, I'm going to factor. 24, I'm going to use the greatest common factor. And 25, I'm going to use SADMAP. Now, just so that we're all on the same page, I want to write out all of the different ways that you can find the roots of a quadratic. Now, if you're trying to find the roots of a cubic, these necessarily do not apply. So graphing, factoring, complete the square, complete the square, and then quadratic formula. And that's my preference order. And graphing is only if they give me the graph. If they don't give me the graph, then I'm not going to go graph it. I'm just going to factor it because it actually takes me a little bit more time to type it in and all this other stuff, because I'm a pretty efficient factorer. Now, when I say complete the square, I really mean complete the square and then use SADMAP, which is the way I'm going to use on this last one. Now, some of you have favorites. This is my order, and there's advantages and disadvantages for each one of these. So I'll just tell you right now, graphing really works well when the roots line up nicely, right? They line up on a point, like 2 or 4. But if your root is like negative 2.7, you can't tell that by graphing. Factoring only works on the ones that are factorable. I know that sounds silly, but it's true. I can't factor. I am not able to factor something that's not factorable. Completing the square and quadratic formula work on both of them, but they are a little bit longer in a process compared to factoring and graphing. So this is why this is my order. So I'm going to factor for this first one because I look at these numbers and I'm like, oh, we can factor these, because I look at 51 and I'm like, oh, 51 is 17 times 3. And if you don't know that, I don't know. I just know that. If you don't know that, then probably your job would be to go to completing the square or quadratic formula. So, all right, so here I go. So I'm going to factor this. If you have not seen me factor, this is how I factor. I'll take my time with this one. So I multiply a times c and I get 51x squared. So I multiply a x squared times c, which is 51, and I get 51x squared, and I put 20x on the bottom. And I'm thinking about what two numbers multiply to get to 51, but add to get to 20. And I just told you they were 17 and 3. So that's that part. And then I move over to my box. And the box goes like this. First term, first box. And I have a couple of videos in case you forgot how to factor. So the first term goes in the first box. The last term goes in the last box. And then these two numbers that we just found, oh, you can't see 17, you only see 7. These two numbers that we just found here go in here and here. And it doesn't matter which order they go, they just go in there. So then the next thing I do is I take out the greatest common factor of x squared and 3x, which in this case it's x. And then I play who's missing. So this is x. So then I say x times what gives me x squared, and you're like x. And then I say x times what gives me 3x, and you're like plus 3, good. And then x times what gives me 17x, and this is plus 17. And you're like, hey, Ms. Johnson, those are the two numbers that I found. Yes, I normally won't use the x box when I'm factoring, but I do this for your benefit so that you guys can all see that. So here's my answers. It's x plus 3 times x plus 17. And then because they told me to find the roots, that means that's when that means when y equals to 0. So I'm going to set this whole thing equal to 0. And then you should know this next step. So the next step is based on your zero product property. And your zero product property goes like this. Anything times anything equals 0. Well, that must mean one of those anythings must be 0. So I'm going to make this anything, equal to 0. And I'm going to make this anything equal to 0. This is why 0 was your favorite multiplication table when you were younger, right? So my final answers are x is equal to -3, x is equal to -17. Ta-da, there's my answers. So then the next question you should be saying is, okay, Ms. Johnson, how could I check this? So yes, this is very important. So one way to check this is when I plug this in, I should get out a 0, right? When I plug this in, I should definitely get out a 0. So I'm using a calculator to plug this in and make sure that I have all the answers correct. The other way that I could check this is I should look at the graph of this, and then where this parabola hits the x-axis should be at -3 and -17. Okay, so those are a couple ways for you to check those. Okay, I'm going to move all this up so I can do number 24. We'll do that so you can kind of see it as I move on. Okay, number 24, I'm going to do in a little bit of a different way because I automatically see a greatest common factor here, which definitely helps me. So I'm going to go with 3x squared plus 12x. And I'm going to take out the greatest common factor. So here I'm looking for what's the biggest thing I could take out of both. And you're like, oh, I definitely see a 3 and an x. Very good. So then I go, this is x plus 4. And so already it's factored. Now, if you factored it like this, you would have came out with the same exact thing. But because I saw a greatest common factor, I knew my work was going to be a little bit shorter. Now, can you imagine doing the completing the square on this? That's a lot of work. Can you imagine doing the whole quadratic formula on this? It's a lot of work. It's a lot of work that gets you the right answer, but still, if there's a more efficient way, that's one of the things that math is supposed to teach you, is your most efficient way of getting to an answer, right? Or if you want to think about it, the laziest way to get your answer. But I guess lazy people wouldn't even care about the answer. I don't know. I'll stop running down that trail. Okay, because I'm looking for a root, yes, I will be setting this guy equal to 0, and then I will be using my zero product property yet again. So again, the zero product property says this times this equals to 0. So set each of those thises equal to 0. So 3x equals to 0, Ms. Johnson? Yes, and x plus 4 equals to 0. And then you solve, you get x is equal to 0 and x is equal to -4. And then I ask you, okay, well, how would you check your answers? And you're like, oh, Ms. Johnson, I could check it by. And you're telling me I could check it by plugging in here really fast, right? 0 plus 0. Yay, it's 0, right? Plugging in here, -4, not too bad either. And then also using your graphing calculator. All right, this last one, x squared minus 11, I'm going to be using kind of like the completing the square idea, except for I don't have to complete the square because there's no middle term. So I'm going to jump directly to SADMAP. So in case you're new, SADMAP is PEMDAS backwards, and SADMAP is the order in which I use to solve equations. So let me show you. So the first question I ask myself is, hey, do you have any subtraction or addition on the x side? And you're like, yeah. And then so you can, oh, well, how do you get rid of, or how do you undo subtraction? And you're like, oh, just add 11. Very good. So now we have x squared equals to 11. And this is the dangerous part about completing the square. So I will show you that. And then you skip division and multiplication because obviously there's none, but there is a squared, right? There is a squared. So then I say, okay, well, how do I get rid of my squared? And you all say, oh, Ms. Johnson, just take the square root. Okay, here's the danger in this part. If you say your answer is x is equal to square root 11, you're actually wrong. And you're like, oh, but Ms. Johnson, I don't know the square root of 11. That's not the problem. The problem here is, see, remind yourself, according to the fundamental theorem of algebra, how many roots should you be finding? And you're like, 2. Good. How many did you find? 1. Yeah, you lost one. You lost one. Where did you lose? I don't know where you lost it, but you lost it. Actually, you lost it right here. So you lost it right here. Okay, so this is the phrase that I use. Whenever you take the square root of an equation, you have to also include your plus or minus. So I say this phrase over and over again because I don't want you to forget. You should be looking for 2. So the place that you lost it, and many students lose it right here, not lose it, but lose their solution. They lose their solution because they forget that x squared has 2 answers. So the little proof in the pudding here is if I say, hey, I have a number and I squared it and it equals to 9. What number could be there? And you're like 3. And I say, yeah, but another number can go there. And they're like, oh, -3. So where did you get those two answers? Well, the fact that when you square something, your sign like kind of gets eaten by the squaring, right? A positive times a positive is a positive, and a positive, I mean, a negative and a negative are positive. Then that's where it kind of goes. So you have to remember to really remember to do plus or minus. Does that make sense? So no worries. If you are actually following my advice and you're checking your answer in multiple ways, you will notice that, oh, wait, I lost an answer. So no, you would not be able to tell that you lost an answer by just plugging in, but hopefully that squared will trigger your brain and be like, oh, I should have had 2. Or when you actually graphed it. So let's actually graph this one just so that we're all on the same page so that you can see what I mean. So when I go to Desmos, my favorites, and I graph x squared minus 11, and I'm looking for the roots. Now you have to remember that the roots are none other than this guy and this guy, where the parabola and the x-axis intersect, also known as your x-intercepts, okay? According to you, let's pretend that you only found the square root of 11. You found this guy, and you're like, oh, Miss Johnson, there's 2. Yeah, there's 2 of them. Where'd the second one come from? Or where did you lose the second one? Well, you lost the second one when you forgot to put plus or minus. The last thing I'll say about plus or minus is my students think that this is a hybrid number. Like, Miss Johnson, how do I plug in plus or minus? Or Miss Johnson, what does plus or minus mean? It actually literally means positive root 11, comma, next number, and negative root 11. Does that make sense? All right. So again, I know there's a lot of different ways for you to solve quadratics. I would say if there was one that you would be familiar with, it would definitely be one of the ones that you could use on every single quadratic. But factoring and graphing are so fast that you might as well learn how to do it. Because look I finished this one in like, what, 2 steps? And this one basically in 2 steps too. So if I'd pick a factoring and then one of these 2, and making sure that you know how to solve all of them. So very good. Hopefully this makes sense to you. And now you're a little bit better at understanding how to find the roots of a quadratic function.